In the notes for 10.3, we're going to be doing the opposite of the distributive property. The title of the note says factoring by GCF, and so this word factoring is going to be important. Anytime you factor something, you're undoing multiplication. And so that is going to be a theme for the next couple sections. And so in the first example here, you'll see kind of what it's going to look like. When you factor out the GCF, you look at the expression, so that's what's typed on the paper, and you're trying to take out the things that they have in common, the biggest things that they have in common that you can divide both of them by. So some teachers call this hockey stick because this looks like a hockey stick. The number that goes in front is the biggest number that you can divide into this number and this number. It has to divide into both of them. And then any letters that go out front are any of the common factors of the variables. So see how both of these have one y? That means that you could also take out a y. We write this in front here, and then these numbers down here in the bottom come from doing division. So 3 divided by 3 gives me 1. You didn't take out any x's, so the x's will stay. And then we took out the y, so there's no y's left. And then on this one, 9 divided by 3 gives you 3 left over. You took the y out, and so there's no y left over, and it's subtraction. When you write your final answer to these questions, whatever you divided them by is going to go in front, and then whatever was left over is going to go on the inside of the parentheses. And so we'll see several examples of this together today. So when you're doing these, the question that you want to ask yourself is, what's the biggest thing I can divide both, or in some cases all, because there could be more than two things right here. But what's the biggest thing I can divide them by? 12 and 15 both divide by 3. 12 divided by 3 gives me 4. I still have an x left over. And then 15 divided by 3 gives me 5. And so that's how you get the leftover. Notice that on this one, I couldn't take out an x because they both need to have the thing that you try to take out. So on this one, I couldn't take out an x because the 15 didn't have an x to take out. When I write my answer, I put the greatest common factor in front, and then I put the leftovers inside the parentheses. One point that I want to make about this is that to check your answer, you can always multiply back and do the distributive property like we learned about in the notes from 10.2. So watch this one. 3 times 4x gives me back 12x, and then 3 times 5 gives me back 15. So that's how you know you can have the correct answer for this one. As we go through and do the rest of these problems, you want to ask yourself, what's the biggest number I can divide both of them by? On this one, the greatest common factor, or the biggest thing you can take out, is the number 3. 6 divides by 3, and so that would be 2. The t would stay here because I didn't take out a t, and then 27 divides by 3, and that would give me 9. So 3 times 2t plus 9 would be my answer for that one. And then we'll just continue through the page. Remember, you have to take out the biggest thing that you can take out. On this one, I can divide both of them by 4. 4 divided by 4 would give me 1, so I would just have an x left over here. And then 64 divided by 4 would give me 16. So my answer for this one would be a 4 in front, and then x minus 16 left over. Remember, when you write your answer, and I'll go back and box these later, but the answer is what the distributive property would have looked like before you started to give you back the thing that they're asking you in the question. So it's kind of like we're doing the opposite of what we did yesterday. On this one, they can both give you a 10, but you want to be careful because 10 divided by 10 is 1, so we don't write that. The a stays a, the minus stays minus, but on this one, 10 divided by 10 gives you 1. You do have to put a 1 right here. So your final answer for this one is going to look like this. 10 in front, and then a minus 1 inside the parentheses. The rule is that if you start with 2 things, you're going to have 2 things left in your parentheses. If you start with 3 things, you'll have 3 things in your parentheses. The things are the number of terms. So it's kind of a good way to check your answer. But notice, look at all 4 of these answers that I've done so far. You can redo the distributive property to check and make sure that you got the answer correct. So 10 times a gives me 10a, and then 10 times negative 1 gives me minus 10. So that's how I know that these are correct. One of the things that the first 4 problems here have in common is that on all of them you're only taking out numbers, but on some of them you're going to have to take out letters, variables, and then sometimes you have to take out both. Look at this one. This one has 3 x's, this one has 2 x's. So if this one has 3 to give, and if this one has 2 to give, I can only take out 2. I can't take out 3 because this one doesn't have 3 to give me. It only has 2 to give me. If I have 3 x's and if I divide out 2 of them, I would have 1 x left over here. And then if I have 2 x's and if I divide out both of them, then I would just have regular the number 1 left over. So remember, to get these numbers, you're doing division. I took out 2 x's, and then I have x plus 1 left over inside my parentheses. On the next one, the first one has 4 a's, and the second part has 6 a's. So you can only take out 4 because you can only take out the least number that any of the terms in the expression has. So on this one, if I take out 4, I took out all of them. So remember, you always have to put a 1 anytime you take out all of them. And then on this one, it started with 6, and I took out 4 of them, so I have 2 of them left over. So a to the 4th in front, and then 1 plus a to the 2nd would be left inside the parentheses on that one. What's probably the most common when you're doing these is you'll have to take out numbers and you'll have to take out variables. And so you want to be careful that you don't try to take out too much. On this one, 6 and 15, they don't both divide by 6, but they both do divide by 3, so I can take out a 3. So I'm looking just at the coefficients, just at the numbers out front to decide this number. Now I'm separately going to look at the x's. This one has 2 x's and this one has 1, so that means I can only take out 1 x. Be careful when you do the division on this one. So 6 divided by 3 gives you a 2 left over, and then you had 2 x's, but you took 1 out, so there's only 1 x left over here. 15 divided by 3 gives you 5, and then you took out the x, so there's no x left over. So on this one, you took out a 3x, and then you have 2x minus 5 left over inside the parentheses, and that's the answer to the question, factored by greatest common factor. On letter H, I can take out a 4 from both of those, and then I can also take out 3 a's, because this one has 3 a's to give me, this one has 5 a's to give me, but I can only take out the least number. Let's see, 12 divided by 4 is 3, and then I took out all the a's, and then 8 divided by 4 is 2, and then I had 5 a's, and I divided out 3 of them, and so I have 2 of them left over. So my GCF is 4a to the 3rd, and then I have 3 plus 2a to the 2nd left over. That one felt a little bit tricky because of all the numbers, so let's multiply it back to check and make sure we did it right. 4 times 3 is 12a to the 3rd, and then no more a's would give me a to the 3rd, and then 4 times 2 is 8, and then 3 a's and 2 a's makes 5 a's. Good, so that's how I know that that one's correct. On these last ones, here let's see, on I is a little bit different than the other ones have been so far on the page, because this one has numbers and it has x's and it has y's, and they both have numbers and x's and y's. So that's your hint that you might need to take out 1 or more of each of those things. 12 and 16 both divide by 4, so I can take out a 4. This one has 5 x's, this one has 2 x's, so I can take out 2 x's, and then this one has 3 y's and this one has 1 y, so I can take out 1 y. And then I'm going to do the division. So 12 divided by 4 gives me 3, x to the 3rd, y to the 2nd. I had 5 x's, I took out 2, and then I had 3 y's and I took out 1. And then 16 divided by 4 gives me 4. I took out both x's and I took out the y. So 4x squared y, that's my GCF. And then 3x to the 3rd, y to the 2nd, plus 4 is what I would have left over on the inside. That last part over here doesn't have any x's or y's because it had x squared y and I took out x squared y. So it's okay that this one right here doesn't have any variables left over on it. And then last but not least, on this one, all 3 of those numbers divide by 3. That's the biggest number they divide by. And then this one has 6 x's, this one has 4 x's, and this one has 2 x's, so I can take out 2 x's. I'm going to have left over 3x to the 4th plus 5x to the 2nd plus 4. Let's see, 3x squared, 3x to the 4th. You do rewrite this in its entirety. I know it kind of feels like you're just copying down the same thing that you just wrote, but you always have to make sure that you put the GCF in front. And then let's just double check the multiplication. 9x to the 6th, 15x to the 4th, and then 12x squared, and so that one checks out as well. On question number 2, it says to describe and correct the error made while factoring completely. Just a point, anytime it says describe and correct, that means that they're wrong. It would say if possible, or if there is an error, or say there is no error. It would say something like that if it was possible that it would be right, but on this one it's not possible that they did it correctly. So you're expecting there to be an error. Look what happened on the first one. They took out a 4 and a y, and the answer to this question says they only factored out the y, but you can take out 2 y's. Look at the numbers that you started with. There was a y to the 4th, and there is a y to the 3rd, and there's a y to the 2nd. So if you can take out more than one variable, or if you can take out a bigger number, you always have to take out the biggest or the most that you can take out. And so on this one, the correct answer would have been to have taken out 2 y's, and then the final term wouldn't have any y's remaining. And so on B, if we take a look at the numbers in the problem and see what they took out, 2, 10, and 6 all do divide by 2, so it was correct that a 2 got taken out. This one had 6 x's, this one had 4 x's, but this one had no x's, and they took out 3 x's. So the mistake in this one is that you can't take out any x's because the final term right here, the 6, doesn't have any x's to give you. And so for this one, no x's can be factored out. The 6 does not have any x's to give, and so we'll do the correct work for it right here. I'll rewrite the problem. 2x to the 6th minus 10x to the 4th plus 6. Notice that the question does want you to correct the error. So on this one, you can only take out a 2. This one has 6 x's, this one has 4 x's, but this one doesn't have any. So you can only take out what it has the most of, x to the 6th minus 5x to the 4th plus 3. And so again, I'm getting these numbers because I'm dividing them all by 2. My correct answer to this question would look like this. My GCF is just the number 2, no x's. And then I'm left over with x to the 6th minus 5x to the 4th plus 3.